welcome to my channel. Today we will discuss on chapter 5, work, energy and power. So in this video, we will continue with the subtopic 5.2c, work energy theorem. So what is the meaning of work energy theorem? Work energy theorem is the net work done on an object is equals to the change in the object kinetic energy. Okay, so we can write as work done W net is equals to change of kinetic energy, or we can write as work done equals to the net force times the displacement cos theta equals to half mv square minus half mu square. According to the work energy theorem, a moving object has kinetic energy because work has done to accelerate the object from rest to a speed. So let us try exercise 2. In a smooth pulley system, a force F is equal to bring an object of mass 5 kg to a height of 20 meter at a constant speed of 3 meter per second. So the first one, determine the force. So for these questions, actually we need to go back to chapter 4, forces, where we need to draw a free body diagram. Okay, so if you refer to this object we have mg, the weight, and there is a tension. So if you are referring to this force, actually here we have another tension, because tension equals to mg and our F is equals to T, so therefore F actually equals to mg, because constant speed meaning that V constant will give you A equals to 0. So therefore we notice that when constant velocity A is equals to 0, tension will equals to weight, and the external force will equals to tension. So therefore, to determine the force, we can use the chapter 4, where we know that force is equals to mg. Okay, so force here, the value we don't know because this is actually external force. M is given 5 kg, G is equals to 9.81, so therefore we will get 49.1 Newton. Okay, next we will go to questions number 1b. Okay, questions 1b, determine the work done by the force. So force here we are referring is actually this force is a F external. So work done by F external is equals to F external times the displacement cos theta. So F external just now we already found 49.1, and the displacement initially is at ground, so it will go up 20 meters. Similar, when you pull down, it will go down 20 meters. So the displacement here is S. S is equals to 20 meter. Cos 180, because your F is going downward but the displacement is going upward. So therefore, we will get negative 982 joule. This is questions number 1. Questions number 2. A stationary object U equals to 0 with the mass 3 kg is pulled upward by the constant force of the magnitude 50 Newton. So this constant force actually we are referring to F external because it is a pulling force. Determine the speed of the object, meaning is V, where it is travel upward through 4 meters. This is the displacement. So we have U, we have M, we have force external, and also we want to find the final velocity when you reach 4 meters upward. So what should we do is we can use work energy theorem. Work energy theorem equals to change of kinetic energy. So when you want to use the work network, you must use F net times the displacement cos theta equals to half mv square minus half mu square. And we know that because u is equals to 0, so the initial kinetic energy is also equals to 0. Okay, so F net we don't know. Okay, later we need to find. S is the displacement 4 meter. Okay, cos theta. Okay, your F net is the motion is going upward. F net is going upward, meaning the motion is going upward, and the displacement also going upward, meaning that is cos equals to 0, equals to half. M is 3, V is the value that we want to find. Okay, so you need to find F net first. So when you want to find F net, of course you need to go back to chapter 4, forces. So we need to find F net. F net equals to the force that similar direction with F net. Similar direction with the motion is positive, meaning that our F external is positive plus weight, because it's going downward, so we must put negative mg. F net equals to 50 is given, minus m is equals to 3, g is equals to 9.81. Therefore, F net we will get 20.6 Newton. Then we substitute into the equations 20.6 times the displacement for cos theta equals to half, m is 3, v squared. So finally, we will get the answer. The final velocity for the object is 7.41 meter per second. So this is the answer for questions number 2. Okay, next one we will go to another questions where the block is in inclined plane. A block of mass m is 2 kg. Slide down, so this is the displacement 0.75 meter. An inclined plane that slopes downward at an angle of 36.9 degree below the horizontal. If the block starts from rest, okay, so meaning that u equals to 0, calculate its final velocity. We want to find v. Okay, you can ignore the friction, meaning that there's no frictional force. So now we have m, we have s, and we have the initial velocity. We want to find final velocity. Okay, so it's easier, we use the work energy theorem where W net equals to change of kinetic energy. So in here again, when you write W net work, so you must take net force. F net times the displacement cos theta is equals to half mv squared minus half mu squared. Again, u is equals to 0, meaning there is no initial kinetic energy. Okay, so F net is the value that we need to find. S is the displacement 0.75 cos theta, because the motions and the displacement is in the same direction, so we can write cos theta equals to 0. Half m is 2 kg. V is the value that we want to find. Okay, so meaning that you need to find F net first. We need to go back to chapter 4. Okay, so we need to draw free body diagram for this object where you need to ask 5 questions. Okay, weight, tension, friction, normal, and also F external. So the number 1, weight, yes, we already drawn. Tension, we don't have. Okay, we don't have tension because there's no string. Frictional force, the question already told us ignore the friction, so we don't have friction. Normal, okay, we already draw. And then F external also we don't have because there is no pushing and pulling force. Meaning that for this object, it's only experienced 2 forces, normal force and also the weight. Okay, so we need to draw. This is the free body diagram for the object. Okay, so we need to resolve it into x and also y component. Okay, where we know that for mg, okay, this is 36.9. Okay, so here will be 90 degree. Okay, so if you look at this triangle, the angle at here is 90 minus 36.9. Okay, so if you press calculator, 90 minus 36.9, here you will get 53.1. Okay, so next, if you refer to this line, the x component and the y component, actually this is 90 degree. Okay, so if here is 53.1, meaning that the angle here between the vertical and also mg will equal to 36.9. Okay, 36.9. So if I draw out, okay, this is our x-axis, this is our y-axis, this is y, this is x-axis, and the normal force is actually at y-axis. Mg is straight downward, so we can resolve it into, this is 36.9, we can resolve it into weight x component and also weight y component. So now the object motion is going downwards. This is the motion. Therefore, we need to find F net. Okay, F net for x component, where our F net for x component is equal to, same direction is positive, opposite direction will be negative. Okay, so here we only have mg, okay, this one is going same direction with the motion. Okay, so wx, so we write as mg is opposite, so it's mg sine 36.9 degree. Okay, only have one x component, we only have one forces. Okay, F net for y component we also have, but F net for y component we know that at the end is equal to 0 because this object is not going up or going downward. Okay, so F net for y component is equal to 0, or we can say actually the normal force is equal to mg cos 36.9. Okay, but this part we can just ignore it because we are not we don't want to find the normal force. Okay, we want to find F net for these questions, so we substitute m is 2 kg, g is 9.81, sine 36.9. So finally 36.9 we will get 11.8 Newton. So you substitute into here 11.8 Newton, where this F net actually refer to x component only, because x component there is an acceleration, but y component is equal to 0, and that force is equal to 0. X component next force is equal to 11.8 because it's not equilibrium, it's accelerate downward. Okay, so 2 and 2 we can cancel. Finally, we will get our V equals to 2.98 meter per second. Okay, next we'll go to questions number 4. Questions number 4 is an object of 2 kg move along an x-axis and it is acted on by a force of F. So figure shows this is the force versus the displacement. The speed of the object at s equals to 0 is equal to 10 meter per second. So actually this is u, the initial velocity. So number 1, determine the speed of the object at s equals to 10 meter, meaning that we want to find at 10 meter what is the final acceleration. Okay, so we know that area under graph, so we can split it into two parts. Part A, okay, this is part A, where we know that work done is equal to area under graph for Fx. Okay, so this is actually a trapezium, so we can take half, okay, this is the work done for part A, half A plus B times H, okay, where half A is 4 plus B is 6 and the height here H is equal to 10 Newton. Okay, so we can cancel, we can get 5, so you will get 50 unit is joule because it's work done. So this is part A. Part B, this is part B, where work done for part B, also area under graph, and this is also a trapezium, so it's half A plus B H. Half A, this is A, where 10 minus 6 is equal to 4, plus B, this is our B, where 10 minus 7, so it's equal to 3, and the height is negative 5, so we just substitute into the equation is -5. Okay, so half times 7 times -5, the answer that you will get is equals to 17.5 joule. And remember, there's a negative, so you must put negative. Okay, now we want to find the speed of the object at s equals to 10 meter. Okay, so why we want to find the work done? Because we can use work energy theorem to find. Okay, so work energy theorem, F total, net means total, equals to half mv square minus half mu square. But now your initial velocity no longer equals to 0 because it's given 10 meter per second, so we cannot substitute 0. Okay, so the work done, the net work done or the total work done is actually work done part A plus part B, meaning that it's 50 plus -17.5 equals to half. M is 2, V square we don't know, minus U is equals to 10, half, U is 10 square. So this one we can cancel off. Okay, so finally our V, you will get the answer is equals to 11.5 meter per second. Okay, for B, the kinetic energy of the object when it is at 6 meter. Okay, so if you refer here, until 6 meter actually is only from 0 to 6 meter. Okay, so we only want to find the kinetic energy, okay, for the first 6 meter. Okay, so what should we do is actually we can use the area under graph. Okay, area under graph. We want to find the kinetic energy during 6 meter. Okay, meaning that we want to find K final. So what should we do is we can use back net work equals to change of kinetic energy. Okay, so because we want to find until 6 meter, meaning that F the work done net, we only take part A enough, where part A, the net work is equals to 50 only. Okay, equals to K final minus K initial. So 50 equals to K final is the value that we want to find, minus initial half m 2 kg, U is 10 square. Okay, so finally K final is equals to 50 plus, this one we can cancel, 100. And our answer, final kinetic energy when S equals to 6 meter is equals to 150 joule. That's all for today. Hope you enjoyed my video. Remember to subscribe my channel and share with your friends. See you on next video, which is we will touch on 5.3 power. Bye and have a nice day.